So I'm going to try to implement the global signals from source code. I'm not really sure how I'm gonna go about doing this, so I'm gonna have to spend some time thinking about it. Hopefully I can reuse the functions. I think I'm gonna have to figure out a way to reuse the functions that they use there. So that both because it is more consistent with the way that they did it, but also because figuring out how to deal with the types is gonna be really annoying. I don't want to spend a bunch of time trying to, because the hardest part about this is like se there are several different hard parts. One is dealing with the function pointers, the class instances, and the other is dealing with the types of the arguments that the functions are gonna take. So I'm gonna have to spend a bunch of time trying to figure out how can I reuse the stuff that they did and change the stuff that they do. It's the way that they do things so that I can have a global. I think I'm gonna try to create a global hash probably, but I'm not really sure like what data to use to keep track of things. You know, I'm not really sure about the structure of the, because essentially I need to build a store or something like that. But I don't really know. So I think one way that I thought about it just now was if I just copy the functions that they use to emit the signals, but then instead of tracking on the signal map, I checked on the other data structure. So first I have to think about the higher level of how this is gonna work. I'm gonna try this by this time. Not really sure how to say this. Yeah, basically when the timer runs out, I'm going to stop. So probably the best way is to think about the way that it works on the browser. On the browser, you have the own elements, and then you can add events using add event listener, and then when the event happens, that function is going to run. The thing is that in order for the event to happen, the browser is going to be the thing that controls. And here I want another object to control what happens. I want to link two different objects together without requiring the objects to have instances of each other. They both have an instance of the global thing. So I could do like it was suggested by someone on Discord some time ago, where you just use the engine or something like that to subscribe signals, so that would serve as the common thing, which is basically, yeah, a singleton, which is the static class. Hmm. Maybe this is the easiest way. So I think there's three classes. The OS is gonna vary. The engine's probably gonna be the same across all platforms, and the main loop is gonna be the same, and scene tree is gonna be the same, I think. So I think engine, main loop are the main class, the main function. But the main doesn't make a lot of sense because the main is more related to like managing the functions that are gonna run. I think engine makes more sense. Engine or main loop. And I think the main loop changes depending on whether or not you're running the editor. So probably the engine is the thing that makes the most sense. But the engine is kind of weird because I remember on the editor hint thing, I don't understand very well how it works. 'Cause it looks like it implements this in a. There's two different types of engines. It's kind of weird to figure out. There's this core bind, and then there's it calls the engine like this. So I'm not really sure how this works. I bet engine does inherit from objects. Maybe the easiest way is just to implement through the engine. I'm just gonna have to test, but I can like I think the reason why they probably do it like this is so that the version of the function that gets called is the version of the singleton that was initialized because it's gonna depend on the operational system, I think, maybe. But I'm not 100% sure if that's the reason. So probably what I would have to do is to implement on this. I have to implement on both, but then call the function from this. I have to see how they call it on the main file. I did just call it like this. And so probably that's the easiest way. I was thinking about creating the hash map and like copying the functionality from the class DB. I wrote down here. And then doing something like that. But I think that's gonna be a lot more work. And it's gonna be harder to figure out. So if I do everything through the engine, then I can just. But I do want to make the distinction though. I don't want to use. So I want to create another function that's called global signals. But the thing is about using the engine is that I'm not really sure if it's the same as the thing that I was talking about here in the previous stream. That's like I would have to route everything. Yeah, I think that the engine is probably the best, but I have to think about what data structure should I put inside of the engine to keep track of the. So I have to clarify what exactly do I want to happen because the main reason why I was thinking about this now, and I think the reason why I have to figure this out, I think. So first, let me explain these things so I can remove them from here. So one of the steps that I had was to figure out. I'm creating the graph. The graph nodes because I want to translate the project that I was building on the front end to use Godot instead. So I created this class here and I'm using modules to create the new class, and then I'm going to try to build the game from C++ source code on a folder that I created inside of the editor to run a bunch of functions that are going to build the scenes without using the editor, and then being able to use the editor later if I want to, because I'm going to have the scene files as well. So what I'm trying to achieve is just to replace the elements that I have on the front end, which is going to be it's basically this thing here that I'm trying to do. So I have this element here, which is going to be a GUI element, and on Godot, GUI elements are control nodes. And on the front end, the way that I was doing this, because the way that I was doing is different because I think things are less coupled than they are on Godot. And obviously because I was using React. So, but basically I was connecting the events here that happened here with the physics engine, which is just a function, I think. I didn't have a class, it was just functions. And then based on whatever the physics is selected or the layout here, or whatever solver is selected, it's going to run a different calculation to update the position of the nodes. So it's basically linking the data that exists here with the function that calculates the positions of the nodes and edges that creates the illusion of the physics on the visualization. So I was thinking about how to do this on Godot, and that's why I created this stuff here, because that's how I'm thinking about it, that it's going to be. So the graph nodes, so the reason why I'm creating the graph nodes is just like an extension of Godot, and this node is going to encapsulate everything that happens within the graph, which makes a lot more sense, I think, than the way that I was doing before. So it makes things a lot easier to think about. So the idea is going to be that I'm going to put the meshes related to the edges, arrows, and spheres as children of this graph node. And then I'm going to run the solver based on the children, which is what I begin to do here. So I wanted to figure out if that's possible on Godot. And I've seen that they use this function here sometimes on some places to basically get all the childrens of the current node. And the way that it works is that the first is going to be the pattern you want to match. So this is a wild character, which basically matches everything. And then the second is the type of the child you want to get. So here basically I'm getting all the mesh instances 3D, which are going to be the spheres. And then I'm going to loop over so if it's empty, I just return, obviously. If it isn't, then I loop over all of them. And for each one, I implement barn sets and update the positions of each one. So it basically returns the typed array node. So yeah. So this I think covers this stuff here, and I wrote down there on another place as well. Also, I think you can pass two different flag variables after, but I don't remember. I think it's if you pass the flag variable, it's gonna run a recursion stance or something like that. It doesn't matter that much for me now. And this is the stuff that I explained about the primitive mesh. So the way that I'm thinking about it is just on because the initialization is going to have to be on the other parts, which is going to be the headless inside of the editor, not here. It's just related to the new nodes. And I think it makes more sense to split this way because of the way that it works there. Or I can try to build a GD extension, which might make more sense. But I think that it's just easier to build modules. So for now, modules make more sense. So I create whatever new nodes I want as part of this module here, which is on the folder that I created on the modules. So any new node that I need, I'm going to put here. And then inside of the headless on the editor, I'm going to put the functions that combine all the nodes together to create whatever I want. So on that function, what I'm thinking about doing is just initializing the meshes, initializing the mesh instance 3D. So I initialize the sphere mesh first with the parameters that I want. Then I use that to initialize the mesh instance 3D. And then that initializes the nodes. and initialize the edges, and then I append or push everything into the graph node here. So I'm gonna have to, I'm gonna basically translate the functions that I had on the front end to this class here. It's just gonna be the graph. Now I was thinking about using the Boost library to, because that's what I did on the Raylib when I was testing the example, but I think it doesn't make a lot of sense. Because the main reason why I used the Boost on the other one is because I didn't have the meshes. So here it's already like the physics and the meshes are already embedded into the engine. So I don't think it makes a lot of sense to just use Boost inside of this other structure. It just makes more sense to use the classes that they have to for the meshes and everything else, which makes things a lot easier to do. So basically, I just need to implement some functions that are going to add the nodes and edges, and then create probably a vector, two vectors, which are going to keep track of the, as member variables of the graph. So I'm going to keep track of them. And then what I was thinking about it is that I'm going to have, yeah, it's going to be a main control node. There's going to be this element here. And then as children, the control node is going to have all this other stuff here. And I think I'm going to try to, I'm going to try to reuse the same logic that they use on the editor, because then I can just copy the functions the way that they do it. They have several standard classes that they use for pop-ups. I think they have probably sliders and these ranges here. And those classes already have the functionality that deal with events, and you can just connect a function that you create to determine what's going to happen after the event. So I can basically copy the patterns that they use. But the problem here is that like these two are going to be siblings. So what I want to do is when a button that is child of this node here is clicked, then it's going to emit an event, and then after it emits this event, it should call a function on the graph node, I think. Yeah, because the graph node is going to be the thing that has the physics visualization. So and the physics visualization depends on some parameters, which are the parameters that show here, the theta gravitational constants. So the question is, what is the best way to link the two? That's what I want to know. So the problem is the connect function. That's the issue. Because on the connect, you need to have a reference to the graph node, but they're going to be siblings. So the question is, how do I connect the buttons on the control node GUI with the thing without using the reference for the graph? That's what I want to know. So basically, that's where the engine comes in, I think. So I think what I have to do is create another function on the engine. And then I have to think about how is this function gonna look like. Because the challenge with doing this, I was roughly thinking about this, is that if I create a global signal that doesn't have any distinction then multiple different things can change based on that signal. So it's going to become more complex the more I want to change the scope of whatever the signal has. So it's basically the same thing with React. So originally we had context, and then this became a problem because exactly this is basically the scope in which we want the context to have access to. And that's the reason why I have state management libraries like Zustand, I think, and others. They basically allow you to keep the scope on a subtree of the main tree for the thing. So the question would be, but the thing is, because I do remember that some of these libraries they felt more complicated than they had to be. So I want to try to avoid doing this, obviously. And I'm trying to think about what is the best way to go about doing this. Because I don't want to spend a bunch of time like remembering React again and studying the source code for React libraries. Yeah, basically on React they had stars. I forgot the name of the other one. I remember Zustand. There was another one that was very popular. Zustand something else. I'm pretty sure that React with Fiber uses Zustand. There was another one. I think it's Recoil or something like that. Yeah, Recoil. And Jotai. Jotai is the one that I was thinking about. So maybe it's worth spending some time because obviously they went through the whole thing about context and then they figure out the problems and how to solve the problems. So maybe it would be better to try to like learn from the pattern that they are using. Yeah, I remember now that I don't remember I do remember there's a very good video, but I don't remember from where that they explain about tree shaking and the relationship between tree shaking and the context thing. And that's mainly the difference between these libraries of state management is that when you want to update two things at the same time, you can have a problem with the context. And then one of these libraries is better than the other for that. But I don't remember really well which one it is. It's probably Zustan that is better, but then the downside is that it's more complicated. I do remember one of the problems with Zustan was to update the store because on React you have to create a new object every time that's uh, there's a that the state changes. So in the store you have to use a bunch of spread operators if you had a nested object, which makes it a lot harder to deal with everything and also probably slower. And then I think Jotai was the one that it was more simple to use. And you just create the atoms and connect them. Or just create an atom and then use the atom to use the. So from what I remember, these are the main ones: Zustan, Recoil, and Jotai, the better ones. Yeah, let me just ask ChatGPT and see what it says. Recoil is the one that has the video that explains the stuff. Yeah, I think Recoil, probably Recoil is the better one. And then Jotai is the simpler one, and Zustan's is probably somewhere in the middle. The problem is like there's two different things because of the nature of the tree and the data flow on the tree. So that's the problem. But I don't think I'm not really sure if it's worth spending a bunch of time. This might be, but probably the thing is I'm gonna face the same problems that they face. That's the issue. I have to try to think about. The biggest challenge is figuring out the scope. So if I do it on the engine, then and the other challenge is the address of each thing. So for example, I'm gonna call the connect on the class that I want the event should be connected with. But the difference is I want anyone to be able to emit that event. And I guess the order matters as well. So basically what I could do, I'm gonna write what I'm thinking about on Scarlet Draw to clarify my mind. And then I'm gonna think about the potential problems that are gonna happen based on what I know about context on React. Which is pretty much the scope, I think. So the main issue is that, which is related to the data flow thing that I was talking about, because the relationship between trees and graphs and the scope is directly related to the variance of data. So the more data you have, the more things become graphs, because trees are just their reduction of complexity, because everything is a graph. Everything can be modeled as a graph on the Cartesian plane. So trees are limitations, and then if the flow of data gets too high, it becomes a graph. But then the problem is that if you want to have like an object that is not a global object, it's just accessible to a part of the tree, because let's say you have, this is the issue that, so the main difference is that on Godot is about the scenes. So each scene is a subtree, so maybe that makes it easier. And the problem is that I'm not really sure how they do it, the distinction between the nodes, the subtrees that represent each scene. I think the way that they make the distinction is that the node that is the root of the scene has the scene path, which is the path to the file on the root of the project for that scene. This is the main. There is some function related to this on the editor, and it's basically the class editor data that is a part of is a child, if I remember correctly, of the editor node, or actually is a member variable of the editor node. It's called editor data, and that class is responsible for keeping track of the scenes. But I don't know yet how does it I don't know very clear how, it's not very clear in my mind how it initializes the scene. From what I've seen, it just copies the one that I already has, but yeah, it's not very clear to me. But it mainly gets the path. The thing is, I don't know, I'm not really sure how it gets the root of the scene. But what I'm thinking about is that's gonna be, each scene is gonna be a subtree, and then I think that makes it easier to encapsulate. But let's say I have a situation where I want like a global signal, but I want it to be limited to this subtree, because I want to, and this is exactly the issue I was having on the front end. So probably a good idea to open the front end code again, which is basically because everything works in components on React, I separated everything that's going to happen with visualization on a component called graph component, I think. And the idea was to be able to reuse that component in whatever page I want. But then the problem with that is that if you manage the state with a context using that thing, it becomes a problem because then if you have two different graphs on two different pages, as soon as you change the graph on one page, it's going to automatically change the other one because they're using the same context, which is global, a global variable. So in order to prevent that, you need to limit the scope, but you still need a global scope because the position of the nodes are relative to each other. So I'm thinking about this probably, maybe not right now, but I want to do things that keep in mind what can potentially happen eventually, because then obviously it makes it a lot easier. Like, once you build things, they get gravitational force because it's just the way things are. So the more you build on top of it, the harder it becomes to change later because then there's a bunch more dependencies attached to that. So once you change something, you have to change everything else. So I want to make sure, I want to be careful, but obviously you want to draw the line of not being on paralysis by analysis. So, and this is the challenge always. So I want to make sure that I don't spend too much time on this, but at the same time that I think about this problem that I'm probably gonna have if I do things like this. And on here, the way that I did this was to use a pattern that they have on the documentation. I think it's the Zustan documentation that they tell you to use React Ref because the Ref keeps track of components somehow. I didn't know very well under the hood what happens. But it's basically the dependency injection pattern using useRef to create different stores based on the ref. So I think because each reference, the useRef is probably a reference to the DOM element that the subtree is, or that the components related to. So when you attach the store based on the useRef, you make it so that the context, the scope related to the store is encapsulated by the roots of that node based on its ref, which is its HTML reference. And then that allows you to use the context in a limited scope. I'm trying to find on the documentation. There's this other library that they talk about. It's called Immer, that is related to the stuff of updating the state, because each time that on React, each time that state changes, you have to refresh the objects because it creates new objects, I think. So if you don't do that, you have problems. I forgot where this is. I don't remember what it is on the documentation. It's here. Yeah, this is the pattern here. So use a ref and then create a star based on the ref. I think that they changed the documentation. But that's basically what I'm doing there. And this was the component. Yeah, so I created the stars like this, and I put this on the other one. So you initialize the store on the use ref, and that makes it so that the scope is encapsulated on the ref, which is connected to the HTML element, if I remember correctly. And then the star is pretty much this object here. And yeah, each time you have to create, each time that the state changes, you have to create the object again. And that's the reason why I use the spread operator when you have nested objects as the value of this thing. But it's very confusing, so ideally there would be a way to clarify this. So let me think about what I wanna do. So the main one is probably gonna be the engine. So the engine is a global, actually. So the engine is a singleton and is a global class. So I can put a function inside of the engine that is gonna work. So this one would, so the question is, so it's much better if I reuse, if I'm able to reuse the connects and the emit. The problem with the connect and emit is that it's going to depend on the object. And so I think that what I always have to do is connect from the engine, regardless of where I'm at. And the way that I do this is by the same way that they do it on the. So I'm gonna clarify this first, then I think about the relative scope, because I think that the problem is gonna be on the scope. Because the first part is relatively easy. So I can do it like this, and then from here I can call connect. So it would be like this, and then connect, and then my signal. But then how would I? Yeah, so this is the part, because then I need to do the same thing. So you have to pass the callable. So I think that the callable could be simplified, but it's gonna take a massive amount of work. The intuition that I have is that it doesn't. I don't see why it has to be that complicated. True, because I was thinking about this. I don't understand why they did multiple different callable classes to create the signals, because you could hold the states on only one callable class and then differentiate them based on the memory variables of the callable class instead of the constructor of the callable class. So the way that it works is that you have basically this one, I think. So I have the callable here, and this one. So one of the things that I really don't like is this thing here. So this basically checks to see if the callable is a custom or not. And the way that you initialize the callable changes the way that the functionality here is going to work. And the main difference is that some instances, the thing is, I haven't studied that much the instances where you don't use a callable or you don't use an nested callable for initialization. So usually what happens is you use a macro, and that macro creates a callable by passing another callable into it. I thought is very confusing, so I don't like this that much. So you basically use this macro here, and then the macro calls another macro, and this one, I think it's this one whenever you are using the editor, and probably when you're running the engine is this one. But VS Code doesn't know because of the way that the macros are defined here. These macros are defined on the build system, on the sconstruct file, based on the flags you pass when you're running scons. But basically, this is the main thing that I don't like, because they create another callable here, and then they initialize this other callable by passing the instance and the method that you pass there to the callable. So in this case would be this instance and this thing. So you're calling this function on the context of this other function here, which is basically going to be the instance of this class here. You're just calling this function from the instance of the class that this function is on. And then you're using this other callable to create this callable here. And then you differentiate these different things that are going to happen based on the constructor of this callable. But I don't understand why they did it like this. Because the thing that I was thinking about is that you can just encode that information on this class here, and then you wouldn't need to have the other. So basically, but maybe that's why, because the types would be a lot more difficult to figure out. Maybe that's why they did like this. Because if you try to differentiate which thing is going to happen inside of the callable constructor, and all the constructor, so it only has one constructor inside, regardless of the circumstance, then it becomes harder to, based on the type, to figure out how to change the information you're going to put there. But it does feel that there should be some way to simplify this. But for my thing there, I think it's just easier to use the same stuff that they are doing. So I would call it the same way. The only difference is that here I would pass the, so I'm just gonna copy. So inside of a callable MP, I'm gonna copy this. So I would have to put a function on the callable MP thing. So this would be engine, we got singleton. And now I don't know if I can do, like, what is the right way to do this? I probably it comes here. So get singleton. And then here it would be maybe I should call engine signal star. And then the structure of this function would be determined by how I want to manage the events. So the class that I subscribed with should connect. Yeah, but the problem is, yeah, it doesn't matter if I have to emit from the engine as well. Because the engine is like a global class, so it doesn't matter. The thing is that the data structure in the functions of the relative scope that this context would have has to be you would be inside of the engine. So it's basically the same pattern. I just have to figure out like, what is the best way to go about, because I don't want to spend a bunch of time studying React again or the source code of React, but maybe that's the best thing to do now. I always think about going back to studying React because like now I know a lot more than I did before, and everything's a lot more clear on my mind. So it would be a lot easier to go over the source code again and to figure out how everything is done. But the thing is that it might take too much time because I remember that is very confusing and there's a lot of stuff that goes on React, especially the parts of events. And what makes it even harder is that like there is a very good video about the event cycle, but it is very confusing. So one option is to just do it this way, the easy way first, and then see. I'm pretty confident that you would work because I would reuse the same stuff. The problem is actually the arguments, because how, but I can just pass, like I can use the same logic that they use on the emit signal because they use other functions as well, along with the emit signal, depending on what callable you're using to initialize the signal. They're just passed down the way that they accept the arguments pretty much. So it's pretty much the pattern there on the emit signal function and the other emit signal function. So I have this emit signal, and then this one calls this one. So they're just basically cascading the methods. So I could just do the same thing. So on the subscribe, you would subscribe the method to the signal. But the thing is, I think the difference is I would have to keep track on the engine of what class subscribed the signal. But I can do that. The problem is if I do it on type, it's not gonna be, because then it's gonna be, if I have a bunch of mesh instance 3D, then one of them subscribes, it would automatically make the other ones. So I need the reference of the class that subscribes, the instance of that class, and this is what makes it very hard to implement, I think. But I think that there's probably an easier way to do it. So just have to clarify how to encode the information. I could encode it on the name. But then I would have to make sure that the name is unique to the class. First, let me clarify exactly what I want to have happen. So when I click the button on the GUI, it should emit a signal, and then the function on the other side of the tree should be called with the updated. So it should emit a signal with the arguments that are going to be the new stuff on the engine, which would be arguments taken from the states of the control node. So we're basically just taking the state on one part of the tree and sending to the other part of the tree through the engine class. But then the problem becomes that if you have more nodes connected to the same signal, then it fucks up the state. So the issue is that you have to create a distinction between the key, and the challenge is how do you create the distinction between the flow of data when an event is emitted. So you have to encode the information somehow on the structure you're using to submit or subscribe the event with. But I want to avoid having to use class instances and stuff like that because I think it's going to be very complicated and it's going to be very easy to make a mistake. So for example, I could figure out a way to get the address of the class here. Or yeah, basically just pass the address of the class and then put that on some some data structure inside of the engine. Yeah, because that's the other problem is I was thinking about if I use the connect, then I'm kind of trapped by the way that they did things. But then, like an easy way to fix this is just to create another function in the same way that they created the other function for emit. I can create a connect global function, let's say, on the engine, and then inside of that function, I just call connect at some point, and then I put some other information. So basically, comes down to what data structure to use to keep track of the events in a way that allows me to have relative scope, and keep, how to get that information based, how to link the thing is going to send and the thing that's going to receive in a way that allows me to control when certain things are going to happen. Problem is that I have to spend a bunch of time thinking because it's not so clear how to do this. Like I can think about some alternatives, but the issue is that they are not. It feels very. It feels overly complicated. So there must be a way. The easiest way that comes to my mind is encoding something on the string. So like based on the string patterns, I can figure out how to create a hash or something like that. That you would have you would have to be more complicated than a hash because I think it's a hash where the key is a string and the value is going to be a queue or a list. And then the list has all the functions that are going to run for that event. So the engine keeps track of the hash and then has a function that is called the stored, which is going to check on the hash to see whether or not it has the event. And I can just copy the same logic that they do on the signal to check if the event was subscribed or not. But then so the structure, yeah, because linking the things is going to come down to the hash. Then you need the vector or list or something like that to keep track of all the functions related to that connection. Maybe it's a nested hash because you need both classes. You need the target and the source and how to keep track of them. So the connect happens. The connect has to happen first. No. The problem is that they are not. They don't have to be strictly linked, let's say. I think that the thing that receives the event has to be the one that connects to it. That makes more sense, obviously. So in this case, I would connect to the events based on the graph class, the graph node. And the thing that is confusing is that the order matters in which way I create the class as well. So I need to make sure. I think it's better if the order doesn't matter because then it obviously makes it easier to get it right. So ideally, it doesn't matter if I initialize the graph node first or before. You can still connect through the engine. And then the difference would be that if it doesn't have, because the connection is the part that you subscribe to the event. So it's not related to when you emit. So it only matters the order when you emit the event, but then you can put a check inside of the function that just doesn't do anything if there isn't anything connected to that event. So it's basically gonna come down to. So the first thing that comes down to is how to encode, so how to make sure that, because I do think that a hash has to be involved, and then how to make sure that the key of the hash is related to the class. And I want to avoid using addresses because it makes things like harder to figure out. Because the problem is that they use the memory pool that they create based on the macro, and this uses the other class that they have, which is memory alloc static. And then like increases the chances that something's gonna be fucked up. But the problem is I'm not really sure what other way to. I guess I can use an enum as well. Like I can create an enum. So, but I think for the scope it makes more sense than enum. So in the enum switch statement based on the enum that uses the sing path, it would be like one way, for example, to limit the scope to the sing. And then I can use other things to obviously like manipulate the scope based on the enum, and inside of the function I use this switch. So the most challenging part is to figure out how to make sure that the ID that I subscribe to is unique when I connect. Or I can do the other way around, where it doesn't matter. So for example, I would have a name of an event called press, but that doesn't feel like it's very good because then it creates too much confusion. So like if I have press inside of the engine, the data structure of the engine, then anything that connects to press is going to run the functions. It doesn't make a lot of sense. Or maybe it does actually. Yeah, maybe that does make sense because then I can make sure that I just create new names whenever I want the. So the link is gonna happen through the name that you pass, which is gonna be the name of the signal. But it does feel that this way is gonna be. It might fuck up some things because like I'm gonna be merging the two things. So what happens? But I guess it doesn't matter because then like the only thing that's gonna happen if, for example, someone creates an ID press event as well on the other stuff that I'm gonna create, which is a global event. All that would happen is that the two different functions would run, I think. So both the event that is subscribed in the normal way and the event that is on the global way. So the way that I'm thinking about now is that, so if I want to connect these two different nodes here through the engine, what I can do is just select a random name that I want. So the link between the two is going to be through the name of the signal. And then I can encode the information based on the name of the signal. So unique, global, because I can, it makes it a lot easier to separate everything. And this would be a hash map. So let me get the thing here. It's probably going to copy the way that they do this one. I'll obviously change. So it would be a hash map where the string name is the signal, and here it would be a list probably. Should be, and then engine. But I do think that it is better to do it inside of the engine class. So I wouldn't do it like this. So the names has to be different than the name of the function there. So this here, so every time that I connect to an event on the engine, you would map, for example, so engine signal store unique events. So obviously one of the things to figure out is what happens if there's already a value. So I think if there is already a value, I should don't do anything and throw an error message probably. Actually, maybe not an error message, but just a message that shows that there is the event already, and then just connect the function. I need to send the data. So like since I'm gonna use the engine here, I was thinking about like I still need to uh, connect the thing that is connecting the event with the stuff that is going to receive. But the thing that matters is what data the thing that is connecting the event is going to send. So I think that's where it gets different. So because here, like this node doesn't need to be aware of the function on this node, because obviously it's going to call the function on the engine. But what it does need is to send the data to the function. But I'm not really sure if it makes sense. Because the question is, what do I put inside of the list? So like I was thinking about that I could put the method bind or something like that, which is a class that holds states for function arguments, for example. So basically, like, or I can create some other class that holds the states of whatever information I want to pass along with the event, which would be coming from the class that subscribes through the event. Because then, once that event is emitted, the engine would have the information to be able to call the whatever function with the data, which probably would be calling signal, just passing the data. So it would be similar. You just call emit signal and then get the signal, the string signal from the thing and the data. So you would basically loop over the list, and then for each one, the list probably would be like method bind. I have to see which one of them is the one used to keep track. That makes it easier to, because it has to be related to the emit signal as well, so it is easier to send to the emit signal call. But I would just basically call the emit signal passing the string name, which is the signal name, and then loop over the list and call emit signal for each thing that it is on the list, pass the string name, and pass the method bind as arguments for the signal. I'm not really sure if that makes sense. I think I'm looking the other way here. I'm confusing it because the one that is going to be, so the one that connects is the graph. Because if I was doing this way, the other approach is to just like, because the thing that makes it harder is that I have to figure out how to reuse the stuff that they use, like the callable and stuff like that, and the signal, the normal way that they do signal. Yeah, I think that like it is a massive problem. Because I don't like the thing as well of having to use the macro, that signal macro to send the signal. I think probably the reason why they do like this is because of GDScript. I would like to avoid that if possible. because like what I'm thinking about now is that, and maybe maybe it should follow the same logic that they do, and then the same thing that connects to the signal emits the signal. So in this case, the control node would connect to the signal, and then it would emit the signal. But then the question is, because I'm gonna have to subscribe using this generic function to be called on the engine. So the question is, how do I make sure I can probably use the bind. So use bind to bind the arguments that are going to be passed to the function. I think I would have to do that. And then I would pass whatever, I would pass member variables of the class that is going to emit the event to this function. So the generic function on the engine would receive would be receiving the same arguments that the emit signal would receive. But the main thing that would change is the method, I think. But the question is, what happens with the signal class? Because the events would be stored on the p signal of the signal class, no, the engine class. Because this p signal would be the signal map would be updated for the engine, and that makes it kind of bad. So I'm trying to see if I can decouple those things. So basically create another function instead of using connects for the function. So I can create a connect global or something like that. And then I can use another data structure. And I still pass the callable. The method information is going to be inside of the callable, as far as I remember. I need to find one that's, yeah, this one passes the argument. So here is just passing the signal and the arguments. And on this one, I guess the callable from the signal map, I think. Yeah, so the signal map, because when you connect, it codes the information on the signal map. And this is the same object that was used when it was connected, because the same object that is going to emit the event is the one that connected to it. So when you connect, it stores the signal data, because this is a hash. No, this is inside of a hash on the object, I think. So that's why it checks here, and if we don't have, then it returns. And then it uses this slot map. It uses the signal data to get the methods, I think. No, I think it uses the connections to get the method. And this is the stuff that I don't like, so I have to see. I think the best ways would probably be to trying to get the stuff from here, just so I can avoid thinking about a bunch of types and stuff with C++. So try to get only the essential things that I think I need from this one, and then create other functions, and then just do completely separate from the signal map. That's what I'm trying to achieve. Basically, I want to remember. So they do it directly from the callable. So the callable is the stuff that is going to have the method, which is the pointer that is passed there to initialize everything. So I have to see how do they, it's going to be on the connect, how do they initialize? It's like, I think, yeah, I basically can copy this. The annoying thing is the function pointer. And the thing is, I want to avoid, so maybe I can just copy the function here. I can copy the type of the function. Because the main thing that I wanna avoid is having to think about this. So the question is, how did they store this? And they start here. So, it just starts here. And the issue, I can't really do this on the engine. I would probably have to do something. I would have to create another class, I think, because of the types. Because if I put the types on the engine, then changes everything. I don't want to do that. So I think I have to use another class. But one, yeah, maybe just easier to use the same class. So let me think about this. And this is kind of the issue because, like, if I use the same stuff, it doesn't make sense. Because I'm trying to do, like, instead of connecting the instance with the function that is going to be called when you connect, like, connecting this instance and then this function is going to be called whenever you emit, whenever this class emits this event. Instead of doing that, I'm always going to pass the same function in the same context, which doesn't make a lot of sense. So what I would want to do instead is, instead of passing this, the function here, I would pass the arguments, like the data that is going to be called, or the data that is going to be emitted with the event. That's the difference. But if I do that, then I have to change everything else, which is kind of annoying. They pass. I could create another function that passes the arguments and then just do that. So store the. And the question would be how to do this. So in the same way that the emit signal works, I just pass the arguments. So I just copy the way that they do the emit signal, and then create a new function. I just wanna have to think about if it is exactly what I'm trying to do. So I'll just put this type here and create a similar function inside of the engine, and then I just store this stuff here. And the only thing is the memory on C++ and dealing with the problems that are probably gonna show up. So like the question would be how to store this on the engine with the name. So yeah, I would basically be doing the things in reverse, I think. So when I connect the signal and the data that is gonna be, yeah, but this doesn't make a lot of sense either. Because the data has to depend on the moment you send the event. That's the problem. So I don't think that's the way to connect them. So I'm probably thinking about it in the wrong way. So on the browser, when you connect, you're passing a callback function from the class to run whenever the event is emitted. So let me think about the way that I was doing here with the events. Let me remember how. I think the story isn't related to the events. Obviously, it's related, but not directly. So how was I synchronizing? Yeah, I think I was using the store to synchronize. Yeah, it was basically this. So these are the elements there on the front end. I think it was the configurator, the main one. So I created these options and then I was rendering these options based on the state. But this stuff here is what shows up there. Shows up here. So it's basically the main things here. I think the main one. And the main one's probably not here. Or maybe it's physics. And so this is the thing, the event comes from the browser. So I'm setting up the event here. And then when the event is triggered, which comes from the browser, which in my case, oh, what would be my case? My case would be from the control node, probably. Because on Godot, the way that it works, as far as I understand now, is that the events on the control nodes are going to be called once, so they're pulled through the Windows window, which is created by the display server, and that creates a bridge with the input event or the input class from Godot. So the input class is updated based on the events that are pulled using Windows functions, Windows API functions. Yeah, update the window created by the display server, and then based on that, it's gonna loop over those events, and then it's probably gonna, I think it calls signals, but I don't remember really well. I don't know if it's on the main starts. That's right. Oh, it's on the OS. Not Windows. Oh, maybe it's on the main start. Or OS run, I think. Yeah, so here, it's basically here. Maybe it's better to put the breakpoint there again. Or to, because I already have some breakpoints, so just go over, like initialize the debugger and then go over this again. Because basically I'm catching the events like on the final stage, let's say, and then I can see what happens when I go back. So, but I think what happens is because everything's gonna be a signal, so it emits a signal, and those signals is probably gonna be through the notification of the control node. So I think it's pretty much through here. I'm not sure. I need to clarify this, the cycle of the how the GUI elements interact with events. It's pretty much all the same, but then I don't know, it's not very clear to me because they change based on the data of whatever the event happens and the class from which the event is a part of. So depending what, for example, you have the button class, and depending on what is the parent of the button class, there's the parent is going to have more functionality, which is the dock of the GUI on the editor. And then depending on that, it's going to change the state of whatever shows up on the button. And usually it's going to be the same pattern where first, yeah, but that's for when there's a pop-up. So first the event's emitted, then some functions are called, then it opens up the pop-up. So on the functions that are called first, it's going to change the label at the whatever's going to show up on the pop-up. And then after that, when it calls the other button, when you click interact with the other button, it sends another signal. And then there's other stuff that happens, obviously related to the other functionality. But what is not very clear is the relationship between, because I know that it's going to loop there on the Windows function. And then based on that, it's going to call a push. It's going to call some functions from the viewport. I think was one of them is push events. Inside the push event is where it's going to emit, I think. Inside the push event, it emits a GUI input probably. And then I think that's the one that's, but I don't understand very well. It's not very clear to me yet. So this function is going to call this. And this function, I think, if I remember correctly, is a virtual function. So everything that inherits from control is going to be able to implement their own version of GUI input. And that's how the other classes do it. Then inside of this function depends on the, you check to see what kind of event was received, and then based on that you call other functionality. So subscribe here. Yeah, virtual void. Is this one? And this is this way, is this function here, and that's the confusing part, I think, because this is the function that is called last there. And I think this function is going to depend on some state that I don't understand yet. It's probably going to be related to how the window is created. I guess what I can do, yeah, but if I search for this name here, it's not gonna allow me to understand much. Or maybe it is. This is probably on the initialization, the constructor of the display server. The display server windows, So display server is the abstract base class that creates the window that is going to be displayed. And then just like everything else on Godot, there's going to be derived classes that depend on the operational system. And those classes are usually the one that are used, but then the type declared on the main function is going to be the one that is from the base class. So in this case, when you compile for Windows, it's going to use the display server Windows class to manage the window. So I guess it sets the main function here. I thought it was going to be harder because there would be a bunch of things. So it uses inputs another singleton, which is a global class, and it sets the function here. So this, yeah, I remember this as well. So this is the function that is going to run there once the window catches an event for the mouse. And this runs this other one. So here it also uses a callable. So it's gonna call is similar to the emit signal pattern. It's gonna call based on the callable, which is coming from the events. This pop-up list. There's another function that like does the bridge between the Windows functions and this display server Windows class here. Yeah, remember I put some breakpoints at some time, but then it stops the flow too much, so I had to remove. But I do remember there's a function like that. So I think through that function they probably change member variable of this class here, and then they store the events on this thing. So here's creating a callable based on this. And this, I think, is because you can have multiple different windows open. So this, it keeps track of all the windows you have. Yeah. The question is how this is set. Hmm. So it creates the callable from here. And so this is probably the bridge between the two. So this is probably gonna and there's also this other one. And this is just binding the method. It's probably this one. It has to be because it's the only thing there. Yeah, so I think that I remember seeing this as well. So this one is going to be from the viewport, this push inputs, and that's where it's going to emit the other signal, if I remember correctly. So I'm pretty sure that it calls this function at some point. Yeah, this one is from the viewport, and this is the one that emits the GUI input, I think. It emits the event that calls GUI inputs. Yeah, GUI input event. And then here it's going to depend on what kind of type, what event it is, and then it's going to... do you remember if it uses a callback? Or it creates the control, and then based on the control node, it's still kind of confusing to understand how it knows where the event happened. But I guess it's just through that bridge there from the window. Well, let me go back to thinking about the global signal. So this case, the browser would be this stuff here. This is just a control node, pretty much. And the browser is the window struct there. Yeah, I think it doesn't make a lot of sense to try to implement the same pattern as the browser implements, because I don't want, like, it's more the event dispatcher, I think, which is pretty much, it's similar to signals, but I think it's pretty much the same pattern because it's the observable pattern. The only difference is that I'm using a global object to implement. And as far as I remember, when you use event dispatcher, you usually inherit the classes from the event dispatcher, and then you subscribe based on that. I'm trying to remember the Pixie thing. It's the thing that I remember seeing this because of the events that happened there. But I remember that I didn't like that much the way that it works. They created another two classes to keep track of the events as member variables, and I think they were queues or something like that. But I don't remember really well how they did it. And maybe it's better to think from scratch because then it might be possible to simplify more. So I have to think that the first function is going to be called. I think I'm gonna run the thing, and I'm going to interact so I remember the flow of what happens. So I'm gonna click on a button there that I know that I have a breakpoint, and then remember how. I think I have on a couple of different ones. I could just put there based on the label as well if I don't have, because I want to remember what is usually the flow that they use, because it's probably going to be the same one that I'm going to use to create the my button there. So it's going to be something where I click a button here or I click the slider, and then it changes the visualization based on that. But if I do something where, like this class, this slider class, for example, is I connect, let's say the same pattern as I put add event listener based on this class here, then I think it doesn't make a lot of sense because then, like, I would still need to have the reference to the other class that is going to receive the events, and that's what I want to avoid. So the question is, when I connect to this, what is the best way to, what do I want to accomplish? Like, do I even need to subscribe to the signal first, or can I emit without subscribing? And what would be the downside of that? The easiest way to think about it is that you don't need to connect to the event, you just emit the signal. You emit the first signal name to describe what the signal is, and then you just push data, whatever data you want to push. And then inside of that, whatever function is going to deal with that, which is probably going to be from the engine, then you figure out probably a data structure inside of the engine, you figure out from that data structure. Maybe it's a better idea to just put the functions now on the engine and then go from there. I think that's probably better. To just create the data structure there on the engine. Because the key thing though is that the challenge is figuring out, because I know I'm gonna have this problem with this scope. So that's where the issues are gonna come. If I emit signal without requiring to register first and then emit to everyone, then how do I make sure that Like there's a way to manipulate the scope of what things are going to happen after the event is emitted. So for example, if I want only two different nodes of the visualization to react to that event, how do I make sure that I can do this? So I can have either the option of this node here emits a signal and then these three things here react based on the data that this one passed, which is obviously going to be through the engine, or I can have the option of this node sends the signal and then only these nodes reacts. So basically, what is the best way to link the connection with the emission? I'm gonna be right back. I'll go to the buffer. I think I just thought about a way that it's probably not gonna fully work. So I'm going to stop here. I'm going to just go to the engine class and write down what I'm thinking about. Because like there is issues with this way. And this is another thing that is annoying is these other versions of the. It's better to go from the way that the editor hints. So this is the. Actually, the other way around is better. I'll probably be here. So what I am thinking about is, for example, creating hash map. Then it will be string name with a list of callables, because that would make it easier. And then here I put engine signal star. But the thing about this is that, so one thing is that what would make sure that the I still think there is a problem with scope, but like you can make sure that the only like you can make the string name unique so that you have more control over how the nodes are going to be connected through these signals. So basically you're encoding that link with the string. But there's still going to be a problem between scenes, I think. Because if I want to create, it's the same problem with React, that if I want to create the same, let's say I want to create a reusable part of the tree. So the same way that they do in the editor there, where I'm going to have the same hierarchy of control or control nodes where they're going to represent a GUI element, and I want to reuse that GUI element on multiple different parts. Then how do maybe it is a good idea to see, or to spend more time stepping over the editor to clarify more how they usually structure things. Because obviously they use the normal signal to pass information. So maybe I'm overcomplicating stuff. So in this situation here, it wouldn't matter. I would create a function here, and then I would emit the signal based on. So I would look for the string that the signal was emitted with on the hash map, and just emit that. So if the hash map has the string, then I loop over the list of callables and call the function. But then the question is, how do you pass the data, the arguments? And I guess you can pass on the emit signal function as well. So on the signature, you put something similar. Or maybe this is the way. The only thing, so maybe this is, like there's two things that are on my mind now. One is whether or not I'm overcomplicating this, because obviously they make it work on the GUI elements of the editor, but I'm not really sure if they have situations where, like how they are doing to connect two different parts, two disconnected nodes on the tree. I'm not really sure, and I don't know how hard it's gonna be to clarify this. Because the main confusion is about who subscribes the signal and who emits the signal. So I do think I have to spend more time stepping over the editor on the GUI elements there on the events to see usually how it happens, and if the parts of the functions that are called and the data that is passed around, if they are from nodes that are from different parts of the thing. But I think that they all, on all instances of the editor, is always going to be a direct flow of data. Or they're just going to pass through the other parts by going to the lowest common denominator between nodes, and then storing the information there. So for example, store the information on the editor node, and then even though you have two different nodes that are siblings, you pass the data through the editor node, which I don't want to do like this. I want to avoid doing like this. So I think it is possible that they don't do what I want to do on the editor. I think that's possible. So the other thing is about the scope that I'm not really sure, because I think that this way that I'm thinking about it probably is gonna work for a simple case, but then I'm gonna run into issues on the scope. So I'm thinking about doing the same thing that they do here. And obviously there's this other annoying thing that is this two different versions of the engine, probably because of the singleton pattern and the different operation systems. So that's probably why they are doing things the way they are doing here. But I assume that I'm gonna have to declare the functions twice, once on this thing here and once on the other version there, just to make it easier. But here, for example, I would have emit store signal. And then inside of this function, so it would be basically the same as signal. So I can just call, so I can see how I have to look for examples on the hash map. See if I can find one. But basically on pseudocode would be like check to see if signal exists on hash map. So if then p name would be here. So if it doesn't, then I return. And return. And then here I would just loop over or get the value. So it would be basically for, and then I think they use key value or something like that. So I don't remember really well, but it's like key value. Or so basically looping, or actually this would be the least. So it's correct, I think, this way here on pseudocode. So this one gets the list, and then I loop over the list. And then these callables here would be everything that is connected to that signal at the moment that it was emitted. So you would run. Then I can call based on the. So the question is, how do they? I think they just do callable. I can basically copy the stuff that they do here, or I can just call this function. I have to create another function because I don't want to use the same stuff that they use here. I can copy the patterns though and just replace with the other data. Not sure if I would need to do this because I would have the callable there already. So mainly this issue here, like this happens whenever for some reason as you're emitting the signal, you lose the information because the object gets destroyed. So they create this new memory here to make sure that the thing is not going to be lost. I don't know very well, but it's basically this issue here. And then this is based on enums that you can pass on the macro, callable MP macro. So if you pass other arguments to that macro, it can either allow you to disconnect after the signal is emitted, so the signal is only emitted one time, or you can put disconnect deferred, and this message queue here is a queue that is going to run somewhere in the middle of the rendering cycle. So it's basically async. So you emit and you want the ones should be called at the same time. So you use this thing here. Because I could do the same thing there. But I think it's not worth it doing this. It's just easier to just simplify and just emit the function whenever the signal is called. So here I would call the same way. Yeah, maybe this works. But then the only question is the scope, I think. So this probably works if I don't care about the scope. But if I want to limit, so maybe an enum is the easiest way to, so I have to figure out a way to incorporate some enum to limit the scope to whatever I want. Enum would force scope to be like based on like predetermined patterns, like different things. It's probably better to use a string name to allow more flexibility. But then it makes things harder, I think. So I think I could put a check, another check on this function, and then I store the thing somehow. So I'm not sure if it's better to do a nested hash map here, or should just create another hash map. It feels kind of bad to create another one because then they're decoupled, there must be more chance to. I think it has to be on the same one, so it would have to be. But this seems kind of complicated. This would be a different string name. Because then what I can do is I can encode on this one. So the first one would be the main signal, or maybe the first one would be the scope you want, and then the other one is the signal. And that way it allows you to encapsulate different things with different scopes. And maybe this way it works. And so I think what I should do is just do it and then see what happens. The problem with doing this is that I have to. I think it's better to. I'm gonna create another thing here, because the thing is I need to create an example. Like I need to create a simple version of the example using the editor GUI. So I have the GUI element and I can test when I run the game what happens to see. So I need to connect first on the GUI, I think, before I do this, because I need to have a easy way to test to see if it's working. So basically what I'm gonna do is just create a button, I think, using a control node from the GUI. Then on that button, I'm probably gonna change the class, or I can create a new class. I think it's better to create a new class because then I'm gonna be able to see if it's my thing or if something else that causes an error. So I think what I can do is just create another another class on the Brahma thing there for a button that is gonna inherit from the normal button. And then I use that one to create on the GUI, on the editor. Then I put the functionality of on that class. And basically I call that the emit star signal from that. So I have to understand, I have to clarify more how they do it so I can do basically the same flow that they do for their buttons, but then just do it from the other class that I'm going to create and then call this function instead of emitting the normal signal. And I think that this makes a lot of sense. So basically what I'm going to do on the button, so let's say I have a custom button class, which I'm going to create on the modules along with the graph class that I have there. And then this one, I'm not going to make it so that I have to subscribe first. I'm just going to emit. So this one is going to hold the data, for example. So it would be like these values here. Obviously, I'm going to test with random data, but then I can store the data on the member variables of this class. So just call the function directly and then pass the So this would have to, you need to have another argument here, which would be, so this would be the p name, and the other one would be the p scope. And then I can get, yeah. So I emit directly, so custom signal, or and then here I pass the data, should be something like this. And I think all I have to do here would be to just check. So I access the value. So first, at first I check to see if there's a scope, then I check to see. So the questions are, on hash map, how, um, how to check if hash map has a key. This is the first one. So first check to see if there's a scope. If it doesn't, then return. If it does, I check to see if the signal exists. If there is a callable for a signal, or if the signal exists. Because if the signal, so when I subscribe to this, yeah, I need to create another. The other function is gonna be just putting the values there. But then it gets to the whole thing that, because this, but maybe this is inevitable. Like it has to depend on the order that you do each thing. Right? So I think it. So I was gonna say that this can be problematic because then let's say because Godot uses multiple threads and it's complicated on the like a lot of parts. There could be a situation where I want to emit these events, and even though I'm gonna connect on the other class, this one runs first, so it doesn't run. That's the problem. So in that way, it makes more sense to force the connection. Maybe that's why they did the way that they did, where the same thing connects and emits, because then you make sure that it is connected first. Hmm. But I think for what I'm trying to do, it doesn't matter that much. Because the event's only gonna happen when you interact with the GUI element. So, and that's only gonna happen after the classes are initialized. So it doesn't matter the order. But let me think about whether or not it's worth to think about that as well. So I think like the way to clarify this is by thinking about the how would the connection function be. So obviously the connection function would have to be, we need to have a callable. It would be the same thing, but with a scroll and with no arguments. So looking into the callable here. So basically like this as well. Right here we would have the scope. Yeah, so for the callable, I would use the same macro that I use because it's easier. And then I don't have to think about on the emit here, how it works. Because like it's basically the same thing that is happening there. The only thing that is simplified is because I'm not taking into consideration, or maybe not. Because the point of not using I obviously can use the connect and emit from the engine, because the engine is gonna have them because it inherits from object, I think. Yeah. So I could just call the engine and then like do the same thing, but then defeats the point because I don't want to have to link the references of the classes with each other when I subscribe and emit. So I want to be able to just emit and then send whatever data, and then whoever is subscribed to that does whatever he wants. It probably calls a function that does whatever he wants with the data that was received. And the data comes from here. Yeah, but this is the problem because this is gonna call a function that is subscribed to this. That's the issue. So I might have to change I might have to use another thing here. It doesn't matter. It doesn't matter. Maybe I can use maybe I'm overcomplicating things and I can just use the signal from the thing. I think that the main difference that I want is that on the normal signal, you have to emit and send from the same thing. But if I'm using the engine, then it doesn't matter. Because the engine would be the thing that emits. No, but at the moment that you connect, you need to have access to the. Yeah, I think that's the difference. So in the normal way, even if I use the engine to be the bridge, when I connect from one class, I need to have access to the function from the other node that is a sibling that I'm not gonna have the reference to. That's the point. So that's the problem here. So the question is, if I did it like this, would that solve the thing? And what is exactly the difference between the two? I think I don't like as far as I can think right now, it probably would solve because here I can put the function of the other class on the callable because obviously it's gonna have access to. So just create callable MP with whatever function I want to run based on the variables there. And so I have to think about, so the callable receives the instance of the thing and the function that is going to run. So what happens if there is a mismatch in arguments? That's the problem. I think that's the issue. So how do you make sure that the arguments that are sent through the event match the ones that of the function that is going to be called? But I guess the way to solve this is just to make it based on the same pattern here. Because I'm trying to avoid having to Obviously, I can create another class that is similar to callable, but just try to simplify. But I want to avoid doing that. So if I can reuse the same stuff, it's better. So in the case that I'm thinking, the graph is going to connect. It's going to call this function. So it passes the scope, which is going to be graph scope or something like that. Then it passes the signal, which is going to be physics changed, something like that. And then it subscribes the function from the graph, which would be like update physics values, which would be, for example, member variables of the graph class. And then that function would be the one that is called when the signal is emitted, and it would be called by passing the checks here, looping over the list, and calling the callable with the arguments. So let me remember what is the callable call p thing. Because I have to call from here. And the callable already has the callable stores the method. And this here, it depends on the way that you initialize the callable. When you use the macro, you're going to initialize the callable with another callable, which means it's going to hit this branch here, because then the callable is custom. And this is differentiated on the constructor there, because it's going to change the way that this callable holds information. So the default way is for the method to be a string name, and this only changes when you don't initialize with another callable. So this means it hits this condition, and then it uses this to call. And this one is going to call the methods from a function pointer, if I remember correctly. So custom is the other custom callable that you use to initialize this other callable here. And this one is the one that holds the information for the function. So subscribe the function the moment you call the macro callable mp. And that's going to hold in this case going to this one, but usually it's going to be the other one, because the macro that is usually used uses another callable custom. This one is used when you use the bind to bind the arguments on the moment you connect the signal. So I have to go to the thing again. It's basically gonna be that one, like this. So this is the one that is gonna be used, if I remember. It's basically just passing the data. The instance is the instance you passed on when you subscribe there, which in this case would be the this, and the method is the function that I pass here. So it's the method that is passed here, and then this is just gonna call that from the instance. It passes to this one. This one is the one that calls. So p instance method. Yeah, so actually I think I can do this in the way that I have there. Because this should probably take care of the situations where the signal that it was emitted passes different arguments than the function that is going to be called here, based on this cast here that it uses the std library to convert the types. And this thing that I don't understand very well yet. This is on this one. Maybe. Yeah, std remove pointer. This one is just using dynamic cast, so it's casting to this thing that I don't know how it works yet. It's probably like the name says, removing the pointer of this type and then converts to whatever type the thing is. So let me go back here. So I think this way probably works. So on this one, I would probably just I have to create the list first. I'll probably use a menu there. I have to see how choose there because I don't remember really well. So basically create the list here. Actually, no, I wouldn't create the list here. I have to check to see if the other hash has the list. If it doesn't, then I create. So if this has a signal, if it doesn't have, then I create the if it does have, I just add to the I think I wouldn't need flags then. I'm not really sure which one because they do optimize this string name here to be used as these arguments on functions. So I'm not really sure if it's a lot worse because usually using enums is going to be faster because it's an integer. Maybe it's better to just use the flags as the scope and then I just create because the problem with that is like I said, it's not going to be dynamic. So I think it's probably better to be dynamic because then it allows more flexibility for encapsulating different scopes. I think it's probably better to leave as a string. This cost's not going to be that high. Yeah, so probably the best thing to do is just to study the GUI events again from the editor, clarify the flow that usually happens, then create a simple example there from the editor, like I said. So create a class. I'm gonna remove. Oh, this other stuff here, let me read this so I can remove from here. But it's basically related to the macros there that I realized that is generated on the build file there. And these are the macros. So this one binds a virtual function, I think. Register a signal for scripts. And then the GD virtual and GD virtual call. GD virtual call is the one that is used to call that function from the macros that I explained on the last string. So I'm just gonna delete from here. And this one is all, so. And this is the part that has been the most confusing, but I'm pretty sure now that you can only emit a signal from the class that connected to that signal in the first place. So the class that connects and emits is the same. The one that makes the bridge is whatever function is going to be run after the class emits. So that's how it connects to the other objects. It's through the function, not through the connection. Which is one of the things that I want to change there when it comes to the global ones, because I think it makes it easier, but you might end up being the same thing because of the scope. So I'm not really sure. But I think it's worth just testing there. Just see if I can simplify. So basically here creates a custom button class, first button umbrella. So I think I can first try to, or first I do it the way that same way that they do it using the signals, like the normal signals, because on the example that I have is not that complicated. So I believe it's not hard to connect here because it's just one level. But obviously I'm doing this other stuff because of the principle, because I think I might need later. So I think on this example I can try to just connect them to the root thing and just like do exactly what they do on the editor, basically. So just implement and then test to see if it works. It does. And so after I do this, then I can change some button to use signal engine. But I think first, before I do this, I'm gonna try to compile with the stuff that I put here. So I'm gonna figure out, I have this other, so maybe I'm gonna put this stuff first. So how to, so basically these ones here. So I'm gonna structure the functions there, the way that I'm thinking about it. And it puts this there. Then I'm gonna compile with the functions. Then I'm gonna do the other stuff. And after that, then I can change the custom button to use these things instead. And then after I do that, if it works, then I can think about whether or not this is gonna be problematic because of the order. Like, the main thing that I'm thinking about is whether or not should I force the signal should be connected before it is emitted. And I'm not really sure if that's necessary. And if it is necessary, then I think it changes everything. But maybe it's not, because I can just like check to see if it exists and then just show an error message. The main thing would be to change, to make sure that the thing that emits the event is the one that connects to it. So maybe I can, I don't remember if I still have the Pixie version. Because I remember the events dispatch from the Pixie example. And this is what I'm trying to remember, how the event dispatcher connects the events. Because I don't think that it is required for the event to be subscribed by the same class that it meets on the event dispatcher. So I think it's different, but I don't remember really well. Oh, this is the Vite example. It's not the same. Hmm. I'm gonna stop here. The time ran out there, so I'm gonna spend more time off stream thinking about this to clarify. Basically, the main thing that I don't know is whether or not it's better to because I do remember, from what I remember vaguely, on the when you're using the event dispatcher on the front end, it's not necessary for the class to connect to the event. The class that emits the event doesn't necessarily have to be connected to that event first. I think it's possible for a class to just emit an event without ever connecting something to it, but I don't remember really well that's the case. Because on the add event listener, obviously you connect directly to the class and then you just subscribe a callback based on whatever the browser is gonna send, whatever message. So I'm not really sure if there's a problem to do like this, because I think that this way is a lot simpler if I can do it like this. So I just connect whatever and then I check to see if it has on this nested hash here. And if it doesn't, I just store the callable there on the list, and then whatever I put here on the callable is gonna run all the functions, and then I can put a bunch of like the same functions on a bunch of different classes. Yeah, it would mainly be the callables that determine what happens. And the callable would hold the instance of the class. And then whenever I emit the signal, the scope makes sure that is dynamic. So I can create a component that is encapsulated by the scope based on an attribute that I put on the nodes, for example. So I could create an extension of the mesh instance 3D, for example, as a module. And then on that extension, I would put a member variable that would be like mesh scope. And then I can create a subtree from the graph that only has these types of nodes with this mesh scope. And then I can subscribe the events based on that. And then that would make the events be like only for the components. And then I can reuse the components. But actually maybe not, because then it would be the same. Yeah. I actually know if yeah, it depends on the way that I initialize the class. So maybe it does work. Yeah, so I could use the dependency injection the same way that the context was in React. So I can put on the constructor of this node here, I can put the information of the scope. And that would allow me to create subtrees. So I can create, for example, another class that is basically the same way that the graph class is, where it's only going to take these types of nodes as children, and then that class would be the same. It would work in the same way that the parent component on React works, where the type of the parent that has the subtree would determine through dependency injection the scope of the subtree, and that creates the context. That limits the scope, and then that one is synchronized with the engine scope there on the hash map of the engine. And then I can subscribe. I think this way works. So I'm gonna follow the list, and I'm just gonna implement and see what happens. And then obviously, so I'm not gonna do anything today. I'm just gonna think more about it to clarify things. But most likely what I'm gonna do next is just implement all these steps here. And then after I implement everything in a test and I see whether or not it works, then I think about whether or not I have to change. Yeah, so not sure when I'm gonna stream next, but this is what I'm gonna do here. So see you then.